Okay, so now for exercise 1, we're going to use the cross syntax just to get you familiar with that as a client. And then for exercises 2 and 3, we're going to let you change to the supplier side. So let's go for the client side, it's much easier, just to get you familiar first. Okay, as usual, open up iPhone Studio, please. And then just create a new project as usual. iPhone Studio 1501. And then brand new projects. Call it maybe, you can call it maybe iterable utilities. Okay, make sure that's stored in the right directory before you say create. Okay, and then you can say okay. Okay, please make sure you complete this step before I go on. Okay, so now if we refer back to the question sheet, just in case you cannot catch up my speed of typing, so you can actually also look at the fragment I gave to you. So that's really the critical part of the exercise. Let me just remind you about yesterday's lecture about the iterator pattern. So let me just go there and let's go over very quickly to give you some idea what to expect now. So if we go to slides and then iterator. Okay, so remember this diagram. This may not be a good one to show. So what about this? Okay, so remember this diagram here. If you actually still have this handout today, so please keep it aside, handy. It would be useful for today. Remember yesterday I said, so now what we are trying to do is to assume that we already have some iterable collection that increments from iterable, and they already implement the new cursor feature for us to use as a client. So now we don't worry about this part as a supplier. We only worry about this part as a client. So we are trying to use the across feature, the across syntax in iPhone, okay, to get a feel how the across can be used. Okay, so what you have to know is, on the client side, the most important part is you have to declare some attributes of type iterable. Okay, after that, whenever you use the across syntax, what you get returned from the iterable is a cursor. And the cursor is going to iterate through whatever the underlying data structure is. Either be an array, linked list, or hash table, doesn't matter. Okay, as long as the iterable, the new cursor feature is incremented, which we assume to be the case, then you should be okay. Okay, go back to your iPhone Studio, and let's make a new class there. And for now, we can just make it easy. Don't worry about the clusters for this exercise. Right-click on iterable utilities. That's the default, right? Right-click and say new class. And you can just call that iterable utilities. Okay, just create that. Okay, it's going to compile, and then make sure you can complete this step. Okay, now the first thing to do is to say what kind of constructor we want to have. By default, it would just be the make feature, right? The make feature. And after that, we'll define a feature section here. And let's say it will be the constructor. Okay? So we have we declared that the make feature should be one of the constructors. So now we're going to do the make. And before we define the make, let's think about what attributes we want to have in this client class. As I said before, because we want to use the iterable, so we have to declare something that's iterable. So before the constructor, create another feature section. We can call that maybe just attributes. Okay? So now you can say, for example, collection here. Okay? Any collection. Collection here should be iterable. Okay? This is really the key. And now, if you go to, just open up a new tab. If you double click on this tab here, you will have a new tab there. Go to iterable, right? You can see the class definition there in iPhone. So iterable is one of the library classes for iPhone. you can see that the iterable has a generic parameter g, and this g is similar to the g you saw for your book class, because in your book class you actually parameterize that by the g, which represent the record type. In this case, the g should be instantiated at some point by the clients by what kind of records you're storing in your collection. Okay. Sure, I'll show you again. So if you open up a new tab here, and then if you go to the search box here, and if you type iterable and hit enter, then you can have that. Of course, make sure you have no typo. Yes?
In the iterable utility class, we need to include the iterable class or it's fine?
No, actually, this is really the top class for all the classes that you want to inherit for the iterative pattern. So remember, for the diagram here, so basically you can see that from the supplier side, I'll be with you, from the supplier side, everything that wants to support this pattern here must inherit from iterable. So that's really the top class we have to make sure you inherit from. By this exercise here, we assume we are going to use the array, linked list, and other library classes which already inherit from iterable. So the work is already done for you. Okay, so let's not worry about that for this exercise. Yes? You mean to make it larger? Okay, the font? Okay, I can do that. Yeah, let me see. So tools, preferences, editor, general. Maybe I'll make it 20 to see if that might be too large. Okay. How about this? Better? Okay. Is it okay for you to actually see this from the last row? Okay, good. Okay, so we have declared some attributes for collection of iterable, but now we have to say what kind of items we are storing in the collection. Let's say in this exercise we're storing just integer. Okay, so that's why we have to here instantiate the g by integer. That's how you use it. Okay, let's do that first. And now, because let's say this is the only attributes for this class, and whenever we create a new instance for this utility class here, we somehow want to initialize that with some collection. Okay, I'll show you how to do that in a moment, but let's make sure we initialize that properly. So here we can say we have some new collection here, which is of exactly the same type as the attributes, because we want to simply assign that to that. So we can say collection is assigned to new collection. Okay? Make sure you catch up this step up to now. And now your code should compile. Yep. Everyone okay so far? Okay. Let me show you one thing, and do this for me. Let's say if you get rid of this integer here, you simply have iterable. And what's going to happen? It's going to complain. Good. That's very useful. But what does it really complain? No, read your message over there. So try to read it. So type has round number of actual generic parameters. So if you go back to the iterable class, the g over here is called a formal generic parameter. That's where you define the generic class. However, from the client side, when you're trying to use this class, you have to instantiate that. Okay, that's why it is complaining. I just want to make sure you know what this error message means. Okay, apparently we have the wrong number, so we have to make sure we instantiate that. So we just say integer here, as we did before. Okay, that's something very important to know. Okay, so now if we go back to the question sheet, and let's say, yeah, we have done, okay, now we want to do, okay, let's say we are making some assumption about the collection of integers we're storing. Let's say we store non-negative integers only, which means when you are trying to pass in the constructor here, so the new collection you're trying to pass over here, if this collection here contains anything that's negative, then it should be, it should cause some contra violation right? That's something we want to avoid. Okay? So what we should do is, we should actually do an invariance to make sure the class invariant for the utility saying that it's always the case that the collection should have no negative integer. Okay, so let's do an invariance, and I'm going to do one for you. You can just follow me. So this will be your very first contract using across. Okay, invariance here. Get ready. Okay, so if you simply write the word across and just type enter, it's going to somehow to complete the code for you. However, the default completion for you is actually, you can see that here the keyword is loop. Okay, so there are 3 possible keywords that can appear here. Okay, so let me write it down for you. Either it can be all, or it can be some, lowercase, and also it can be loop. So either of the 3 keywords can be replaced here. Okay, loop is the final case. So you have to know very well that in the case of loop, it's actually supposed to be an implementation instruction. Okay, we actually see a use case for that. Implementation instruction. And for all and some, as I discussed yesterday in the lecture, it's actually some Boolean expression. And remember what each one of them corresponds to? Remember? For the all, it would be the universal quantification, right? So that's a symbol for that. And this is a symbol for the existential quantifier. Okay? So it's very likely that later on in the test or exam, I might simply just give you some mathematical expression and tell you to convert that into the cross syntax in iPhone. That's most likely to be the case. That might be easier than the other way around, right? If I give you the iPhone and tell you to come up with the mathematical expression, that might be a little bit harder, I suppose. Anyway. Okay, so now, as I said before, the loop is supposed to appear, here the default completion here, it is only supposed to appear in the body implementation, but not in the place where a Boolean expression is expected. So in this case, the loop is wrong, so we just have to override that. So in this case, do you think we need all or some? Because now we are trying to say, always, all the integers in the collection should be non-negative, so it should be all. Yes, you're right. Okay, so first of all, let's change this keyword into all. Okay, so now you can see there are 3 placeholders here. The first placeholder, second one, and the third one. Okay, the first one should be some expression of type iterable. So when I say expression, so that includes the possibility of either a variable, which is the case of this exercise. But I think yesterday I also showed you another example in the slides where you can put some expression here that is of type iterable. Okay, you can review the slides for that. But let's here. So here we should put something that's iterable. So apparently collection would be one possibility, right? So that'd be a valid case for that. Put collection here. So that means, and remember, collection here is of type iterable. And if some class is actually, if it actually inherits from iterable, let me go to that architecture diagram. If some class inherits from iterable, then the one feature it will support for sure is the new cursor feature, right? Okay, always refer back to the architecture diagram to make sure your code or your design properly instantiates the iterator pattern. So this here is simply a template. So let's say later on in your projects, if somehow I tell you to justify your design decision or to present your design, you're supposed to somehow instantiate this diagram into your particular solution. Okay, that's the idea. So, okay, the point is, since the iterable interface or deferred class defines the new cursor feature, so that's always available. And the across syntax here implicitly call the new cursor feature. Okay, so what you have to do is to say, for example, as cursor. What this is saying is, implicitly, IFO compiler is going to call collection.newCursor, which is valid because it's defined in the iterable class. And then it's going to assign whatever return value for the new cursor is to this cursor variable. So this is like a dummy variable, like a new fresh variable, so that we can use this cursor in here to define some Boolean expression. Okay, so far so good? Okay, now my question for you. I said this is the cursor that's returned by calling the collection.newCursor. What's the type of this cursor? I can refer back to the diagram and tell me what's the type.
Generic type? Or is iterated?
Iterated? There's no iterated type actually.
Iterable.
Iterable? No. So we are talking about, iterable is here, and you actually return some new cursor here, right? If you look at the architecture diagram, yes. Integer, no, it's not. Integer is the item we are trying to store in the collection, but now we're talking about the cursor that points to the collection, so it's different. So let me try to illustrate this to you. But I think that you guys are getting close.
Iteration cursor?
Very good. That's exactly the answer. Well, A plus for the lab session, although it doesn't count. Yeah. Okay, let me show you something here. So let's say if this is the underlying data structure here, let's say this is from the supplier side. This is conceptual. So this is from supplier, which has some array implementation, right? So let's say the array indices start from 1, 2, 3, 4, 5, 6. Okay, this is some implementation. So we have some reference name called imp. Okay, this is the supplier secrets, which the client knows nothing about because it would say feature none, which is exported to no clients. Okay, the idea about the new cursor is somehow the client can get access to this array by an iteration cursor. So on the client side, so you can see here, so collection dot new cursor is going to return back to the client some iteration cursor objects. Okay, and this cursor objects is going to gradually change its position to iterate through the underlying collection. So you can see that this collection.newCursor, the client does not have to define that. So it is defined somehow by the supplier. So it's completely encapsulated in the implementation for the new cursor. Okay, but as far as the client is concerned, they only have to call the item fourth or after feature to actually determine how to iterate through the underlying collection. Okay, so this is the client side, and that's the supplier side. That's really the essence for the iterated pattern. Any questions about so far? Okay, so once you understand this well, then I think the rest will be straightforward. We'll see. Let's go back to IFO Studio here. So as I said, implicitly IFO is going to call collection.newCursor and then assign that value to cursor. So now here we can use the cursor just like this object here. Okay, and remember there will be 3 features supported. So we have item, so we have fourth, and we also have after. And by now you should know how to use them very well because you have seen some example for the linked list, right? Okay, so now here the only feature we need from that would be item. And item, what should be the type of item now? Good, integer, yes. Yes. So now what we want to say is for each iteration that the cursor goes through the collection here, the value of the stored integer should be non-negative. So what should we say here? Greater than or equal to 0, right? So that's exactly correct. If you compile, it should compile. Please make sure you put this correctly on your editor, and then, okay? So please make sure this one is, although it's very simple, but it basically shows everything you need to know about how to use the across syntax in the context of contracts. Okay, let me say one more thing before I answer your questions. So if you go back to the question sheet, so if you have a look at the invariance there, I'll make it larger maybe. The invariance I put there is actually using a for all expression, right? I'm saying that for all the item, which is integer type, such that item is a member of the new collection. So I'm saying the new collection is simply some collection that's represented secretly in the supplier. It should be the case that the value for item should be greater than 0. So please make sure you know how to read such expression in mathematical form. We might do some little review maybe in the next lecture or before the midterm to make sure you are refreshed with the ideas. But it's very important to, if I give you any expression like this, and you should be able to translate that into across. There was a challenging exercise for you in the slides. So where you have to somehow nest the expression for across. So remember, let's say for the for all expression, you can say, for example, you can say I and j of type integer. So here you're introducing 2 dummy variables. But if you want to translate such expression into IFO, what you have to do is to introduce 2 across construct and nest them together. Okay? It sounds a little bit terrifying, but give a try and I'll give you a solution on Wednesday. Of course, don't try to wait until I give you the solution. You can just try it out, right? Okay, that's just some preview for next lecture. Okay, so I suppose we are happy with this. Okay, so now basically, what this is going to affect the runtime is whenever we pass any new thing to make, and it's going to, after this assignment is completed, the invariant is going to be checked by the IFO runtime to see if it has been established by the constructor. Okay, we can run some test cases already, but we'll do that maybe in a moment. Okay, now let's do some queries, which will be very fun. And I'm going to let you do it since you kind of know the syntax already. The first one I would like to do is, so if you go to the second page of your question here, okay, always we do contracts first and then we'll see how to do implementation. So now let's do the feature that will return a minimum from the, so minimum, okay, so it's a feature of type integer and it's going to return the minimum value in the collection. Okay, and here we're going to, first of all, we're going to do the ensure first. So remember, because this is actually a query, so we definitely have some result value here. Yeah, it's a result value here reserved for us to say what. So the result will be the return value from this query here. So now we want to use the post condition to specify what that return value should be by using the across. As you can see, I already gave you some hints mathematically. So you can look at what I have here. I said this is the post condition. For all the item of type integer that's in the new collection here, I think this is slight typo here. This should be collection, not new collection. Okay, because collection is the attribute name. So I'm saying, so for all the item that's in the collection here, the result, which is supposed to be the minimum, the name of the feature there, should be less than or equal to each item. It's because the definition for minimum is such that the value of minimum should be less than or equal to everything in the collection, including itself. Okay, you may not be so convinced. Let me give you one example. Let's consider, so I guess you are fine with this diagram here. Okay, let's say we have an array. Let's say this array, we actually have, let's say 3, 2, 4, 1, and 6. In this case, Which one is the minimum? 1, right? So now, imagine that we're going to check to see the result. Okay, result is actually equal to 1, right? This is our computer results. But now we want to make sure 1 is really the minimum. The way we check that is to see, first of all, is 1 really less than or equal to 3? Is 1 really less than or equal to 2? And etc. for the others. And also, it should be less than or equal to itself. And also, less than or equal to 6. You can see we have, so these are exactly the predicates or the Boolean expression that will be evaluated at the runtime to make sure the result is really the minimum. So you should really get true for all of them because it's for all. Okay, any question about the mathematical expression here? It should be fairly straightforward. And now it's up to you. I'll give you 2 minutes to think about how to convert that mathematical expression there to the across syntax. Okay, you got 2 minutes. Question? Yeah. Hyper Studio? Okay. Okay, so you got 1 more minutes, and then we will Okay, so Hyper Studio done. So let's go over that. Okay, so let's now say. Okay, so now we're going to, because now we're going to define some Boolean expression here. So if you type across, and the default loop is not correct, so we've got to change that to either some or all. All, right? Because it's a universal quantification, right? So now, tell me what to do.
Collection as cursor.
Across what?
Across the collection as
Collection.
collection. And the dummy variable can be anything else.
Yeah, can be anything, right?
Cursor.
Cursor, let's say, okay, and then?
And then after the cursor dot item, less than.
Oh no, go ahead. No, that's okay. Go ahead. Just finish. Okay, somehow you can see cursor the item. This item here refers to the current element being examined. So this guy here is the result, right? Because the result is 1, let's say. And this guy here on the right-hand side of the less than or equal to is the item that's currently being looked at. So what should we put here? Any? Did you say something? Yes.
Itself should be a result on the left.
Result on the left, I agree. And then, so you mean say should be result less than or equal to cursor the item, right? Yeah? Okay, very good, very good. Okay, good. So you have done your second contract using across. Very good. So now, let me now switch the context a little bit. So far, we have seen how to use the cross syntax for writing contracts of iterables. Now we're going to see how you can do implementation for iterable, okay? But somehow don't get confused. You have to always be clear whether you're writing implementation or you're writing contracts, okay? So now we're going to switch the context a little bit. Okay, now, how do we find a minimum? That's the question, right? How do we find a minimum?
Take the first item and just compare with the others. And if the element just less than that one, just update the result to the.
Somehow, yes. But somehow you have to iterate through the collection, right?
Yeah.
Okay, let me show you 2 ways, as I said in the exercise sheet. Let me show you the one that's not using the across, which might seem more intuitive to you, which is using a loop. And then I'll show you another one that uses the loop, the across. Okay, so now collection if you put a dot here, it will just give you only one feature completion because remember collection inherits from iterable. And the only feature that's defined in the iterable is the new feature. And just to confirm with you again, so if you go to the definition for iterable, and if you see the here under the groups, you can see the only feature that's available here is the new cursor, right? That's why when I want the code completion, that's the only possibility. Okay, so now collection, the new cursor is actually a query of type iteration cursor, right? So I need something to capture its value. So let me say, I would say local, and then I would say, let's say, I'll just say cursor. Okay, so what should be its type? Iteration cursor, very good. However, this wouldn't compile. How come? Maybe let me just say somehow we want to assign the cursor to this. I'm pretty sure. Okay. However, writing this wouldn't compile. How come? Why this wouldn't compile? You actually need to somehow not collection. Okay, I want to hear the correct answer. Yes. Yes, you want to instantiate that. So that's the term to use. So because if you go to the iteration cursor, by the way, there's a shortcut in iPhone Studio. If you let's say you want to go to the definition for this class here, Control right click. That's how you go there. So Control right click. So now I'm now in the iteration cursor class, and it's also generic, which means if you're trying to use it, you have to instantiate its formal generic parameter to be some known class. In this case, it will be integer, as you can guess. Okay, so here we have to say integer here, and that should compile. Okay, good, thank you. There's some, okay, somehow, okay, this is also a good point to illustrate. You can see that this cursor here is a local variable, and this cursor here is a new dummy variable I'm trying to introduce in the cross. However, they clash. What does that mean? Choose a different name, of course, for either one. So either you rename this to be something else, or you rename this to be something else. Okay, it's up to you. But I would say, what about, I'll simply say IT cursor, iteration cursor, but I can choose whatever name you like. Okay, if I say compile, that will compile. Okay, so now what we get is an iteration cursor. Okay, so how are we supposed to use it? If you go to the iteration cursor class, and you will see that it defines, let me show you the feature view. You can see that it defines iteration cursor here, and then we have, you can see there are actually 3 features there. So either you can call the item here, or the after, or the fourth. Okay, these are the features you can use to iterate through the, to use the cursor to iterate through the collection. How are we supposed to do that? Using a loop. Let me do something for you here. So if you type from, click enter. So this will basically give you the skeleton for a loop. But for the rest, what should you do? So apparently this part tells you to do some initialization for your loop. This part tells you to specify when to exit from the loop. And this part tells you in each iteration step, what should you do? But later on, we talk about other concepts like looping variants and variants, but it will be for later on for the course. Okay, so now what should we do now here? One thing I can tell you is, which will make your life easier, this part may go to here to say now we are initializing some cursor. Doesn't matter if you put it here or here, they are the same. Okay, so now what should we do? Any idea? What should we do for the, now you're trying to find the minimum, right? But you need some way to actually walk through the collection. So, Hmm? Index. Well, we're talking about index that lower, but lower is not a feature in cursor, right? Right? Yes.
You exit until the cursor is false.
Very good. Until it is after it's true. Until it is true. Yes. Until it cursor dot after. If I can type it right, yes. That will compile. And now, and in each iteration step, I should say it cursor dot fourth. Agree? So this is basically what you should type before you even encode your logic of computation. So so far, this is only the logic for using the cursor to walk through the collection by using the cursor that's a return from the iterable objects. Okay, I hope so far it's clear. Okay, now what's left is to say in each iteration for this loop, how should we update the minimum that we want to return, right? Any suggestion? Okay, so this should be maybe back to your 1020 or 1030, right? So what we can do, okay, is to say, for example, we can say we can simply say the minimum has to be set to something, right? But because we actually constrain all the stored integers to be non-negative, so what can be the minimum? Zero, right? So let's just temporarily to set it to be 0 to begin with. And then we'll gradually compare with each item there. Because the minimum you can get really is 0. That's the, yeah. Okay, so we would say result is simply assigned to be 0. This line is not so necessary, but you can put it if you like. So now, we should somehow to say if the current item I'm looking at is actually, you know what? This is not so good, actually. Because if you set a 0, it may not be overwritten by. Yeah, very good. So what should we do here? Very good, very good. Yeah. However, we don't have the precondition saying that the collection should be non-empty. Somehow you should say that, right? So this is a place where you should put a precondition. I'll leave that to you. So here we should say require, and then I'll put a comment here. The collection should be non-empty. That's something you should put. Okay, so now that will be left to you as an exercise. I can tell you what. I can tell you this require is not as simple as you might think. You know why? Because collection does not have a isEmpty feature defined for the class. Remember, it's actually in the iterable class, right? So if I go back to the architecture diagram for you, you can see that it's here. So the iteRable class has only one feature there called new cursor, right? And somehow you have to see if the if the iteration cursor class does not have any isEmpty feature there, then what you need to do is to define some auxiliary function there to say how I can calculate the size of the collection. You see what I mean? Okay, let me make it more explicit for you. Okay, so what we can do is we can define some auxiliary function. So we better create a separate section for this. So we can say feature here. So we can say sign auxiliary function. Okay, and here we would say size of collection, right? Let's say it's going to return some integer and have some implementation. So assuming that this feature is somehow completed, what we can do is to use that auxiliary function in the contracts that we want to write. We'd say the size of the collection should be greater than 0. You see what I'm doing here? Okay, so now you'll be up to you to actually define this auxiliary function. And now this time should be okay, because the initial size should be 0, and you can gradually increment it by 1 in each iteration, right? Okay, this will be left as an exercise for you. So later on for your contract, for your project or assignment, sometimes you might think you might find that it's difficult to have some one-line expressions for your pre or post conditions, in which case you do need some auxiliary function to help you, okay, which is totally acceptable. Okay, that's good. So now, given that we have the precondition that the size of the collection should be positive, which means should be at least 1, so what we can do is we can assign the result, which is the minimum, just temporarily to be the first one. Okay, so the first one should be somehow the iteration cursor. Okay, you know what? Let me show you this way. It might be easier. Okay, so first of all, we get an iteration cursor, and then initialize the result. Okay, sorry for the mess. The result should be equal to it cursor.item. Okay, this is to say we are being returned a new cursor, and as soon as we get this cursor, the cursor is in the first position in the collection, is in the ready position, and now we are assigning the minimum temporarily to be the first item. Okay, and we're going to repeat the loop until we finish, until we get to the end. And now, what should we do here? We need some if then else, right? If you type if space, if what? Okay, now here you're gonna think about what to do. What should we do now?
If it's less than 1, it's next.
If somehow the minimum so far is actually what? Maybe let me say it this way. If the current item you're looking at is less than or equal to the minimum so far, then you should really update the minimum so far to be that item, right? Okay, that's something you have to say. But how do you say that in iPhone? That's my question. We don't have collection, actually, IT cursor event. Okay, so IT cursor dot item, right? I keep typing this wrong, actually. Item, so this is the current item we are looking at in the collection. If somehow it's less than the minimum so far, which is the result, okay? If that's the case, then we will update that, okay? We'll say result is assigned to be IT cursor dot item, okay? Please make sure you can follow what I've got into so far. Okay, sometimes you might find that this might be because you're repeating the same expression here twice. It may not be so convenient for you. So alternatively, what you can do is to say current, for example, you can say current integer being looked at of type integer. So this is like a local variable. So it's going to capture the current integer you're looking at. So here you can say current int is assigned to be it cursor.item. If you do that, you can now reuse this name twice. Okay, I'll stop here and then let you think. Agree? Basically, at the beginning of the iteration, I'm going to capture whatever the item that's currently being pointed at by the cursor, capture that as current int. And I can then reuse that for checking the condition here, and also for the reassignments for the result, if necessary. Yes?
Removing the going to the next element, why are you doing it at the last? Because you already assigned the first one to the first element to the result, yeah?
Mm-hmm.
So you can do it at the front.
Oh, I see what you mean. So you're saying the fourth can be moved to the front. Yeah, you can try that. Yeah. So basically, your name?
Yes.
Yeah?
Yes.
Kyosan. Okay, so what Kyosan was saying was, because we are assigning the first item to be the temporary minimum, so that means we don't have to compare that with itself anymore. Okay, so what we can do is somehow we can maybe move the fourth in the beginning to say now we directly move to the second. Okay, but you can try that to make sure it's really okay. It seems to be okay, but you gotta try that. To me, just doing one more comparison it's not going to make any difference. But if you write that, write either implementation in the test, you'll be okay. Yes.
What's the reason that you're using the currency element here?
Oh, the reason is because you can see that if I didn't use this, I have to repeat IT cursor.item in two places. The first place would be to use that to check to see if the current item being looked at is less than the result, the minimum so far.
Yeah.
And the second place is if we have to reassign the temporary minimum, then we have to use that value again. So you can see each time we call this, it's like to getting access to the cursor. So it's actually less efficient.
Oh, that's efficient.
It's less efficient. But, well, in the case where you get a very huge list,
But it's not wrong.
It's not wrong. It's not wrong. Question?
When is the item is implemented? Which
You mean you mean the cursor position on the item?
like
The cursor, yeah, here, fourth. So, okay. So one more reminder, okay. So this part that's highlighted, okay, this part is the only part that's irrelevant as far as the cursor movement is concerned. So you can see that we have to first make sure we return a new cursor to get the cursor ready, and then we have to make sure we exit when there's no more item to look at, and then we have to make sure we gradually move the position of the cursor to right, one at a time. Okay, this part is about the logic for your computation. Okay, so far so good. Okay, so now, this is one possibility of implementing the minimum using the iteration cursor. You can see that the disadvantage for this, but so far this is correct, I'm not saying this is wrong, but the disadvantage for this implementation is you have to explicitly declare some local variable. You have to explicitly declare some local variable here called IT cursor to capture the value for new cursor from the collection. So the across syntax makes it easier for you. Easier, okay? So you can get rid of the local variable declaration, and you can also get rid of this initial assignments. That's why I can buy you. Okay, let me show you how that can be done. So I would suggest we simply just copy and paste this, and then we can define another feature called minimum 2. So you can actually contrast the two implementation. Copy and paste and just call that minimum 2. Okay? And it should still compile. I thought this is easy, no? Okay, minimum 2. So now we're going to use a different way of implementing this. First of all, we can get rid of, basically, we can get rid of all the local variables. Yes. Get rid of them. And now, okay, just make it empty, basically. Okay, now we're going to use across again. So now, across, enter. And this time, the code generation here for you is correct. Because now we're in the context of the implementation body of some query. Okay, so it would be very similar. So the reason I'm putting this is you really want to make sure you only put a loop inside a do block, and you actually have to put all or some for the contracts. That's something very important for you to remember. So now what should we do? Collection, right? It will be very similar. Collection is cursor, let's say. So now we would say if, right? If the result is less than, okay? And just write it down. So now this is something we have to put. I think you should be able to have the current int. Let me try this. Current int integer. Let me see if this compile. Let me try that. Okay, so you can, so here, whatever that's inside this loop add is just normal implementation that you can write. Okay, so you would say current int is assigned to cursor.item, and here you actually say current int. Okay, this works. However, what's the problem now? Have a look at this. There's a problem here. It compiles, that's okay. So basically we're saying we're going to cross the collection as cursor. Okay, so implicitly, IFO is going to call collection.new cursor for you. And then we say the current integer we're looking at is assigned to be cursor.item as before. And now we'd say if the result is less than the current one, then we reassign the result. But what's the issue here? Yes?
You didn't initialize the result.
I didn't initialize the result. That's what you're going to say, right? Good. Okay, in this, yes?
Do we have to advance the cursor?
Say that again?
Do we have to advance the cursor?
Oh, good question. So you can see that I didn't put any line like to say, very good question. I didn't say cursor.fourth. Make sure you don't put this, okay? Because, yeah, that's something I forgot to mention. What this across expression by you in this context is you don't have to declare the cursor variable, and also you don't have to define to call the updates operation for the cursor. It will just do it for you automatically. Okay? Very good question. Okay, I will put a comment here, please. Don't put this. Okay, now back to the more serious question. Here we haven't really initialized the result, which means the minimum so far yet. Okay, unfortunately, in this particular case, somehow you have to get the first item from the collection, right? Unfortunately, so I'm afraid to say we still need a new cursor. IT cursor. However, this is just to illustrate to you the syntax, so you have to judge when you're developing your own application which one might be easier to use. So iteration cursor of integer, and here IT, so we're going to use this cursor just once, is equal to collection.new cursor, right? And we're going to say result is assigned to be IT cursor.item. Yes, thank you. Okay. You might be a little bit confused. So this seems to be more complicated than the loop version, right? In this particular case, yes. But I think later on in your application, you can choose either one. So in some cases, actually this part is not so necessary. Just because for this particular problem we are trying to solve, we do have to initialize the minimum to be the first item. That's why we need that. Okay? But the point is, this is the, the main point for this exercise is you have to really compare these two across. Although both of them are using across, this here is actually an instruction. And this here, using the context of contract, is an expression. Different. This is a Boolean expression here. This is some loop instruction. So they're completely different, although they are both using across. So never try to use the loop here in the contracts. Never try to do that. You wouldn't compile. Okay? That's about this exercise. Any questions before I move on to the next? Good. Let's do one more. I think we have another query for you to do, which is has. Okay? Basically, has is going to tell you if a particular integer is in the collection. As you can see, now you have to do both the implementation, which will be very similar, but I'll leave it up to you. And also you have to make sure the result represents if the integer you're trying to find is really in the collection. It should correspond to this expression here, which is using existential quantification. So we are saying there exists some item in the collection. So again, this is a typo. In the collection, such that the item's value is equal to the one you want to find. Okay, there exist at least one. Okay, so let me just write out a signature for you, and I'll give you 2 minutes to complete it, or 3 minutes. So has, so here, so we have v of type integer and which returns a Boolean. Okay, and now I'll leave the contracts and implementation up to you. And in this case, we don't really, okay, now tell me something. Do we need any precondition here? For example, in the case of minimum, we have to assure, we have to require that the collection is non-empty. Well, I mean, the size is larger than 0. Do you think we need that precondition here for the has? Yes or no? No? Okay, I have a no. Yes? No? Anyone say yes? What would happen if we say, I add this precondition here? What would happen? Okay? If I say require here, and then I would say size of collection is greater than 0. If I put it there, what would be the consequence of that?
Not be able to search for an empty collection.
To see if any integer is there. In this case, yeah, so what he, okay, sorry, I'm very bad in pronunciation. Anyway, so that's exactly correct, because if we do this, that means if the client is trying to see if integer 0 or integer 3 is actually in an empty collection, then they wouldn't be able to do that because it will violate this precondition here. Okay, so in this case, is this precondition considered as too strong or too weak? Too strong, right? It's too strong because it disallows some value that should have been allowed. Okay? Well, that's a little bit hard to understand this way. So it disallows some valid value for the arguments. Okay? Forbids some value that's valid. Very good. So now I will also comment this out. So you can do also comment for yourself. You can say too strong. Okay, so now try to complete the ensure first by translating, converting the existential quantification into a cross syntax, and then do the implementation. I'll give you about 2 to 3 minutes to do it. And then once this is done, then you got a basic knowledge about using a cross. And then we can move on to see how, on the supplier side, how can we make such constructs supported. Okay? Okay, give you 2 minutes or 3 minutes. Yeah, for the implementation, it's up to you whether you want to use a loop version or the cross version. Doesn't matter. You can just choose any one you feel more comfortable. Yeah. All the loop. Oh. Yeah, feel free to discuss with your colleagues, that's okay. And then once you get too loud, that means you're ready. Are you done? No? Okay. Sure. That's a very good question. I'll talk about it. Very good question. Remind me again if I forget. Yes. Okay. Let's see. Sure. Okay, somehow, okay, however we see, what you're trying to do here is to say the truth of the result is equal to the current item is actually equal to the but it's not exactly. In your case, we're trying to say somehow you want to do some system modification throughout the connection. And then you mention the sign. This one item that's not essentially mentioned. Should be true, for example. So you should have actually moved the result outside. So we should say result equals across. That's what we should say. Okay. It's a difference. Because now we're trying to say the truth of the whole across the threshold equals going to be true of itself. Rather than saying individual result, each information. Okay, now let's talk about this. Okay, so let's do this together. I can see some confusion here, but which is okay. Let's do the post condition first. Okay. Post condition first. Apparently, we somehow want to use the across, right? Let's write across first. If you do that and change this, okay, one of the questions you guys just asked me was, what's the difference if you put loop or all? What's the difference, okay? It's a huge difference, actually. I think I really have to emphasize this again. I can see you guys actually gave a huge confusion here. I think that's actually because IFO actually separated notions of contract and implementation. Okay, so there are two things you really have to be clear about their difference. So one is the implementation. Okay, the other one is contracts. Okay, implementation basically, for example, you have some assignments, and you have the if then else, and you have maybe a loop, etc. Okay, that's actually constructs for implementation. As for contracts, you actually have precondition, postcondition, and variance, and they are the Boolean expression basically. So they're the Boolean expression. And what kind of operators can you use for Boolean expressions? You can use and, you can use or, you can use implies, right? The logical operators. And in IFO, you can use, for example, and or and then. So I explained the difference between and then in the class. Okay, make sure you understand the difference between them. And also you have or else. And also you have implies in IFO. So these are the main three. Or also equality, of course. Okay, assignment is equality. Okay, so now these are just examples. They belong to different categories of syntax. So the implementation, we call it instruction, because they are the step-by-step instructions for your computer to execute. So that's why they are implementation. You're telling the computer how to do it. Here, the contract, you're telling your clients what you're going to achieve. So it's like a how versus what. So here, they're called the simply just, I would say, expression here. So one thing you can, one hint to help you is, usually for the implementation, you do want to have side effects on your system. You would expect that by writing an assignment, I'm going to change something somewhere in my states. And after running the loop or checking some if then else condition, I'm actually going to change some variables. However, when you are specifying the contracts, you never modify the states. They are only evaluating the current states. So there's no side effects. So that's why I said. So back to your question here. So the when you have the across notion here, if you have the or here, it belongs to this category, the contracts. So that means it's a Boolean expression. Okay. However, on the other hand, if you have the loop for the cross, it belongs to the implementation category. Yeah.
Suppose all input go over the collection object.
Yes, both of them will, but the return type from them is different. Okay? If you say, for example, across all here, the whole thing is actually Boolean expression. The whole thing, the one I highlighted. Okay? And if you change this to loop, this type here is not expression. It's actually some instruction. It actually tells the iPhone what to do step by step. Okay? Very good question. Okay, I remember there was another question about how we can exit the loop earlier if we find the elements. We'll do that once we finish the post condition. Okay, so now we have to have all here. We all agree with that. Oh no, not all. What should we use? Very good, very good. You guys are better than me. Okay, so now we should say collection here as, let's say this time we don't use cursor, just use something else for fun. Okay, so let's say it can be anything you like. Huh? Oh, okay. My cursor, I, or anything, you know, I, let's say. Just want to illustrate to you, it can be anything you like. Okay, so now what should we do? Somehow we want to say there must be some elements in the collection that corresponds to the V, right? This is how we check the result, right? So we want to say that I.item should be equal to V, okay? So what this is going to do, this is a cross expression here, its type is Boolean. It's Boolean type. So we're saying go across the collection here, and then to check if any of the elements is equal to V. Okay, the whole expression type is Boolean. But now somehow we want to link this expression value here to the result. How do we do that? Very good. You mean here? Here? Oh, okay. Okay, this. Okay. I think this will compile. Let me see. Okay, this compiles. However, it's a very good try. Okay. So now, anyone disagree?
Oh, wait, equals.
That's equals.
Should be dot
Dot.
Oh, you guys are confused again, which is okay. But okay, it's okay to make mistakes now rather than in the exam. Okay, why is this wrong? Why is this wrong? No. It's an assignment, and remember, now we're in the contracts, and we cannot use other construct from other category, right? Okay, please make sure you know why this is wrong. Okay, but that's a common mistake. You're forgiven. What's that? You mean what's this? Oh, sum. So sum means across the collection, is there some element that satisfies the condition you specify? So this is a condition. We say the result should be equal to item equals V. Okay, so now, okay, now let's have a look at this. Anyone disagree with this post condition here? Everyone agrees? You disagree?
The result will be false unless it's the last item that is V.
Result will be false if the last item is V.
Unless the last item is V. The last item is V and the result will be true, but only in this case.
Okay, so, okay, very good. Let me illustrate this. But I think that this can be a common mistake that you can make. But let's make sure you understand this properly. So what this is asserting is, whatever result value you have, okay, we're actually going to go through the collection and then check to see if each item is equal to V. And the value for that should be equal to the result. Okay, let me give you one example. Okay, Okay, let's say now we have let's say we want to check has 2. And if we have this collection here, okay, tell me, in this case, what should be the result from has 2 on this collection here? It's false. Okay, let's try to run this to try to check to see if the post condition will be satisfied. Okay, so the result currently you think that should be false. Let's say that's a return result from your implementation, and now we're going to check to see if this false is going to satisfy the cross there. So what this cross is to say, we're going to say the false is equal to the truth of this. Okay, so now the first iteration here, we can say false, okay, equals that 2 equals 3. Okay, 2 equals 3 is false. False equals false, true, right? This is okay, and it's gonna be the same throughout. So all the return result will be true for each iteration. Let me give you another one. So I just want to give you one example to warm up. So let me give you one counter example. Yeah, 1 second.
Goes from left to right.
Hmm?
Goes from left to right.
Left to right, yes. Okay, so let's consider this example here. Okay, it turns out, okay, since I did this implementation, this contract here is also correct. Okay, but let's make sure it is really correct. In this case, what should be the result for this? Should be true, right? But let's do one case. So you have true is equal to now 3 equals 6, right? And this will be false. And we do true for the second one equals 4 equals 6. And this will also be false, right? But as we reach to the fourth one, we say true equals 6 equals 6. In this case, we'll get a true value, right? Okay, because we are doing the existential quantification, so as long as one of the iteration returns true, then the whole thing will be true. Okay? That's good. So it seems to be correct, although it's not so similar to the expression I gave to you, but it turns out they are both equivalent. Let me show you the expression I gave to you again. So you can see that I actually put a result outside. Okay? So there are 2 versions to write. Either you can say this, okay, you can put a tag here, version 1, okay, and you can make it indented better, okay, and now version 2 would be, you can say result is equal to the whole expression here, and try to convince yourself that these 2 expressions are equivalent. Yeah, it compiles. Okay? Okay, you can see that basically we are moving the result outside of the across. It turns out it's the same. Think about why. And we can, yes?
So you can use either one.
You can use either one. Both of them are correct.
So you should you should erase one, right?
Oh, actually, since both of them are the same, I just want to show you. Both are okay. Yeah. You should just use one, yes. Yeah.
So if there is no brackets, the first 2 are there first.
Oh, good question. So it depends on the associativity. Yeah. So I think that there should be a bracket, yes. Good point. Yep, there should be a bracket here. Yeah. Okay, good. So now, what should be the implementation for this? Okay, so let's say we use the normal loop. Actually, in this case, we don't have to. Let's just use the okay, so either you can say across, right? So you can say across the collection as, here we can say cursor, okay? Remember, not to put any fourth here. And then we can say result is assigned to be what? Now here's your part. So now we are crossing the collection here as cursor, and now how should we update the result? Result should be equal to, yeah, assign. Okay. Cursor dot item equals v. That's what you're suggesting. Say that again. So what do you want to write?
Because after that, if it's false, then
It's going to override the result, right? Yeah. So the problem for this implementation here is, let's say if somehow, well, basically the final result is going to equal to the last check in the iteration. So somehow this is not so good. Okay, there are two ways to fix this. Either you can say that if cursor.item equals v, if it happens just once, then I can assign result to be true. That's one way. As long as I should go into this loop for once, then you will be satisfied. This is one way. Okay, that one should be straightforward. Let me show you a better way. Okay, this one is not wrong. Okay, so now maybe I'll comment this out. Again, that's version 1. Don't put both of them. Version 2. So version 2 would be, we can say result is equal to result or okay, why would this work? Why would this work? Yes.
because one is true and the rest.
Yeah, as long as you get one of these true, then true or anything will be true, right? So basically, if you think about, try to recall your study about the existential quantification. Remember, the existential quantification is like a generalized OR. Basically, trying to OR all the expressions in this predicate together, okay? And for the universal quantification, it's a generalized AND, okay? That should be quite familiar to you, okay? So now let me show you one more thing for the implementation. So this will also work, but you can choose which one to put. Let me, again, put this into comments, and let's do another one. Let's use a normal loop. Let's say let me uncomment that and show you one more thing. The greatest, yes. You can also do that. You can also do that, yes. But I'm going to show you what's the disadvantage for this. Oh, sure. Okay, the disadvantage for this is, as you can see, in this cross here, there is no way for you to break the loop in the middle. Let's say you have a long list of 1 million items, but the item you're trying to find actually just sits at the first position. And this across here has no way for you to exit the loop once you find the elements. You actually force you to go over the whole collection without exiting earlier. Okay, so that's the greatest disadvantage for that. So if you want to have a more potentially more efficient solution, this is how you do it. Okay? So you would say from, okay, let me have a cursor variable here. Local, let's say item found. So this is some Boolean flag that will actually let us to exit the loop earlier. Okay, this should be some technique you know already from Java. But I just want to show you how to do that in IFO. If the item is already found, that means we can now exit from the loop. Okay, earlier, and then we have the IT cursor or just cursor. Cursor would be fine in this case. Cursor iteration cursor integer. Okay, so now we can say from IT cursor. Yes, thank you. Cursor is assigned to collection dot new cursor, right? Until either cursor dot after. Let me just show you the normal way. So now we can say cursor dot fourth. So here, because without a cross, so you do need a fourth statement here. So now we can say if the current item is actually equal to the one we want to find, then we should, for example, set the result to be true. And also at the same time, we should enable the flag to say item found is assigned to be true. Okay, basically we want to say in the current iteration, if we have just found the elements, then we enable this Boolean flag. And it is going to affect the next iteration before the next iteration is run. So the next, okay, let's say after executing this current iteration here, we're going back to the beginning of the until condition to check. So somehow we want to include this item found in this expression here. Any suggestion? How should we do that? We want to say if the item is found, then we should exit. So we say it again. So what should I put here? Until, okay? Okay. Or okay. So you're trying to say we're going to exit either the cursor reaches the end of the list or we have not found the item. No, item found is by default false, but eventually we're going to set it to true if we find it. Oh, okay, that's okay. If, let's say by default is false, right? So if false, this will be true. Then the whole thing will be true. That means you're not going to enter the loop at all. This is the exit condition. Okay. Okay, item found will only, okay, item found will be false initially, agree? Okay, so initially, so in the very first iteration, okay, item found is false. Not false would be true. True or anything would be true. Until true will just exit you from the loop immediately, which means you wouldn't even go to the first iteration.
We want true, we want
Oh, that's okay, that's okay. So basically, item found will be true only if you have found the item. So initially, you haven't found the item yet. You don't even know if the item exists, so that should be false. What you really are trying to say is item not found as a variable, okay? You got to think about this. I know you're confused.
Or we can set this as item found.
Item found equals false.
Yeah, it should be false initially, right? Okay? Okay, don't get confused. Okay, so now item, let me write it out explicitly. Item found equals to false, because initially we don't even know if the item is really in the collection, so that should be false. As I said again, if you set this to be false, which has to be the case initially, however, if you have this as your exit condition, it's going to be not so useful because you're not even going to your first iteration. You're just going to exit from the loop immediately.
If we take the not out, it will work.
Yes. Yes. If you do that, then it will work. This is to say, we will exit the loop if any of the following two cases occur. Either if we are at the end of the list, or we have already found the item in the previous iteration. Okay? But I think you guys are willing to try. That's very good. So all of those are actually common mistakes. So just make sure you don't make those mistakes in your projects and assignments. Okay, that's good. Okay, that's a more efficient version for checking to see if the item is in the collection. So, however, there's no such flexibility for the cross syntax. Okay, so this is only possible for the loop. Okay, let me just go for 1 more minute to. Okay, basically we have completed exercise 1. I was hoping that we can complete exercise 2 as well, but that's okay. Let me just give you a preview very quickly. So you should at least try to do over the weekend or maybe by next lecture time, exercise 2. Exercise 2 is very simple, although you need a little bit of work to extend the shop projects, okay? I'll try to create a video possibly for exercise 3 because that one is actually much more challenging. If I ever put exam or test question, it will be like question 3, not like question 2. Question 2 is like a warm-up. So you do want to warm up before you do the challenge. Okay? So please do me a favor. Try the question 3 yourself while I'm making the video for question 3. That's the deal. Okay? I'll see you on Wednesday. Thanks for coming. Yes. Well, let me stop recording first.